All right, what's up, people? I'm about to go live again. You know what time it is. I'm live again. You know what time it is. It's another Friday. We're about to do a coding challenge. Every Friday, I'm going to try to do a coding challenge. This time, we're going to do a medium problem called container with most water, which this one's pretty interesting. It's probably different than all the other problems I've done on live so far. I just did it like maybe an hour or so ago. I just did it off the cuff. I'm not going to do it off the cuff for y'all, but I'm going to do it in front of y'all, and I'm going to try to do it just from memory and try to explain what I'm doing kind of as if I was in an interview. And then y'all can help me work through it. Like if you know the answer or if you have tips to do stuff better or code it a certain way, you can let me know. But yeah, I'm going to do this medium problem from KG.codes coding challenge. So yeah, let's go ahead and do it. TikTok by Leah, what's going on? What's going on? Yeah, let's hop on here and do this. I think we're live everywhere now. TikTok, Twitch, YouTube, Twitter, or X or whatever it's called, Facebook, we're everywhere. So we about to jump into it without further ado. I'm going to jump to this problem called container with most water from KG.codes. It's a medium. Dang, I don't have the companies because I don't have LeetCode Pro anymore, but I'm sure this is probably asked at some big companies. I'm thinking like one of the Fangs maybe, and maybe like Airbnb or something like this. Seems like they'd ask something like this. Let's jump into it. So this problem is called containers with most water. You're given a integer array height of length n. There are n vertical lines drawn such that two endpoints of the ith line are I and 0 and I height at the index of 1 or I'm sorry. So basically they're saying like you have a array with heights that are n, or you have an array that has a certain length that you call that n. And then on each ith line, it starts at 0, and then there's another point where there's like a height. This is kind of confusing, like how they explain this here, but I think it's gonna make more sense when you look at the picture. They want you to find two lines that together with the x-axis form a container such that the container contains the most water. Return the maximum amount of water a container can store. And then notice that you may not slant the container. So I think it'll make more sense when you look at the picture that they provide. So they basically give you an array of integers like this. So it's just an array with different numbers. Each number represents a wall or like a height of the container, like a side of the container. And so basically they want you to find the combination from they basically want you to find two lines, so like two container sides left and right in this list of container walls that can at most hold the most water. So like if you see in this example, line number 2 and line number 9, I think, is the one that can hold, between these two, can hold the most water. Because they're they're far enough from each other and they're high enough to actually make the most area of water together. So these two are the highest, but like these two together don't add up to as much water as this line and this line. So your algorithm needs to figure out what's the max water that can be held in this whole thing based off using two lines as a container. So it's kind of like almost like a little like a dam or something. I don't know. But it's kind of an interesting problem, a little bit different than usual. So yeah, so they have an example here. This picture is the example. Here's in code, you just get an array called height with all the different heights of the walls here. So like first is 1, so it goes up to 1. The place in index 2 or index 1, I'm sorry, is 8, so it goes up to 8 here. 6, and it goes up to 6 here, and so on and so on. And the output is 49. So basically they're saying here, these two red lines are the place that can hold the most water. The water line is at 7, And so to get the answer, you need to multiply 7 times the distance of the two walls. So like if the first wall is 8 and the last wall is 7, these are 1, 2, 3, 4, 5, 6, 7 apart from each other. So that would be 7 times 7, which gives you 49 as far as how much this can contain. And somebody on YouTube, you the man, what's going on? He said, ask why not 8 times 864? Because the water line is only at 7. That's a good question though. But the water line is only at 7. And this red line and this red line are 1, 2, 3, 4, 5, 6, 7 distance apart. So you measure height times distance times like width, I guess. And you get 7 times 7, which gives you 49. So, yep, the above vertical lines are represented by this array. In this case, the max area the blue section can contain is 49. So, this is the max possible area of water that can be contained in this whole array of different walls of the container. So, I hope that makes sense. Yep, length time width gives you the area of water. Somebody asked that. Whichever height is smaller, move that pointer left or right. A mod B, you're on it. I think you kind of know what you may have done this before, or you at least know what to kind of do. Just reading some comments. Sliding window problem. 2-pointer approach. Yeah, we're gonna see what I'm gonna do. But yeah, I like these answers in the chat. So yeah, I'm just looking through some answers. All right, some questions. I'm sorry, comments. Anyway, let's keep going with this. There's another example where if like there's 2 with just 1, then you just get an output of 1, kind of like a minimal example. There's some constraints here. So if you're in an interview, you might have to ask for these constraints, or they may give you these constraints. But here they're saying that n, which is the length of, they already told you that, so I don't even know why they put that down here. It says length n. So I guess they're saying that, yeah, height length equals n. And they already told you that. So I don't even know why they put that in constraints. LeetCode usually doesn't do that. Anyway, we always guarantee, this is important, we're always guaranteed for the length. I guess they put it here for clarity, but we're always guaranteed that the length, how many walls that we have, are going to be at least 2, greater than or equal to 2. So we're going to at least have 2 walls, so we don't have to handle an edge case when we don't have 2 walls. That's important for an interview or for handling a problem like this. And then we're going to have up to 10 to the 5th power. That's important too, because the algorithm needs to be able to scale up to 10 to the 5th power amount of walls if we had that. So we can't just write any old algorithm that can't perform well enough to handle that. Which this isn't really a lot, but you know, it's enough. And then the height of each one can be up to 10 to the 4th power, which is pretty high. But I don't think, based on JavaScript and the things that we're going to be using, integer, the important thing to notice here is that like the numbers aren't going to like, at least in JavaScript language, like the integer numbers aren't going to like overflow or cause some sort of issue. So yeah, that's the problem. And now LeetCode got some ads in here, which is, that kind of confused me. I was like, what the heck is that? Maybe they always had these here. I don't know. But anyway, shoot. Yeah, these are hints and stuff. I'm not going to look at any of the hints. But yeah, if you're in an interview, you may need to clarify these questions. It may be more ambiguous than this. They may not give you all this information like LeetCode does. So you may need to ask questions. And so like how I like to do these, if you ever watched me before I do one of these, is I like to kind of think about how I would solve it in my mind and then take what I know about data structures and algorithms and translate that to code after. And then of course I need to ask questions. So the first question is like, how do I even calculate the body of water like this 49? Because that's what really I looked at when I first did this problem. Like, how did they get 49? And I said, okay, well I see the water lines here and I see a 7 here. So I know 7 times 7 equals 49. So that already gave me a clue that like this 7 is being used in the calculation. And then where's another 7? There's a 7 on this bottom wall here, but that just means the water is right here. The other 7 is the distance between these two lines that got selected. So 1, 2, 3, 4, 5, 6, 7. So 7 times 7 gives you the 49. The other thing I observed here is that water can only go up to the lowest barrier. That's very important in this problem. The water line can only go up to the lowest barrier. Water can't go up this high because it'll spill out this time. So this problem didn't say that, but it really is how much water can it contain, without just spilling over. I mean, I guess that's obvious from the question, but I mean, that's something important you need to know for the actual problem that you're doing. So anyway, when I'm looking at this, the thing that comes to mind is that I need to be able to select two sides. So automatically going into my toolbox, I'm thinking about a 2-pointer approach. I need to be looking at two things at the same time and making some sort of calculations between them. And so how can I figure out what's the max? Whenever there's a problem with keyword like max or most or something like that in it, I'm always thinking about how can I just try everything, every combination here, and then just figure out which one is the top one. I always save the top one. If I see a higher one, then just save the higher one as the top one. And I always just keep track of the max that I've ever seen. So in my mind, what I'm thinking I can do is simply I can look at the first one against the last one, calculate the water based off the formula that I talked about earlier. It's just the length times the height here. Calculate the water and just go through each of these, compare each of these to each other and see which one has the most water in it. Now really that's the way you kind of have to do it. You need to know what each wall height is and what the water is compared to another wall. And so what I could do is start on this side and then start a pointer on this side and then just do the calculation and see, okay, how much water I got. Then move one of these in, compare. So let's compare the first one to the next to last one, see the water between that. And the one thing to know is if this is 1 and this is 3, then the water can only be this high because this is the shortest wall. So I always need to calculate my water based off the shortest wall. And so then I just keep moving the left and right pointers over, squeezing them in together until I get to the point where they're both the same, and then I'm done. And then whatever my max water I calculated is, that's going to be my answer. So that's basically how the problem works. I know it's a medium. It's supposed to be a little bit harder. Maybe it's easy for some, maybe it's harder for others, depending on how much you've done this. But the one thing and not get tripped up on this one is it really is just an array problem. It's a array type coding challenge. You're doing you're just looking at an array, you're processing it, you're trying to figure out something about the array. The pictures kind of in the water and all that stuff is kind of a nice facade to put over the top of the problem to make it more interesting. But at the end of the day, it simply is you just looking through this array and making calculations based off the numbers in the array. So some people, it may be easier for them to simplify it away from this. For me, it actually does help to see this picture and visualize something versus a lot of the other coding challenges when they're just simply arrays and there's no pictures, there's no story behind it. At least this one got a little story to it or whatever. So anyway, I'm not going to keep on talking about the problem. I'm about to move on to the solution. I just talked about what I think I should do. I basically want to just start on each side and just squeeze in and just as I go calculate the water. I think one important thing to note is that as I'm looking at one and I'm looking at so let's say we start off with I'm looking at the first wall and I'm looking at the last wall. After I get done calculating this, I don't want to move both in. I want to move in one of them so I can basically compare each thing to each other. And how do I want to do that? Well, basically based off how water has to sit in here, I don't ever want to I basically want to take the highest one and move that one in, Or wait, shoot, now I'm getting confused. Do I want to take the lowest one and move it in, or take the highest one and move it in? I think I want to take the I think I want to take the lowest one and move it in. I don't know. Actually, I'm gonna start coding and see which way I need to go, because I actually can't remember. But we'll see. Let's move over to the code. So, well, first I'm gonna take, because some people are gonna join later maybe, and they not know what problem we're doing. So let me just take this, copy it over here. So LeetCode, what they do is they stub out this for you. So I know somebody's gonna come on here and ask, why is this var? So I'm gonna go ahead and change this to a const, because somebody's gonna ask that. And I'm like, why is that var? And I didn't do that. That's LeetCode that does that. And so our parameters is an array of numbers, like they said, called height. And I'd rather this be called like heights. Like, it's kind of weird that it's height. This might screw up LeetCode though, but we'll see. It's called heights, and then I'm gonna put the problem in here. This is it's gonna be hard to read, but I might have to zoom out a little bit. Yeah. All right, so I'm zooming out a little bit so people can see. Yeah, it's container with the most water. So people can see what this is. Yeah, there we go. So, like I said, how do we want to start this out? Well, I know I want to do a 2-pointer approach. So let's create some pointers on both sides of our heights array. So I know these pointers are going to change, so I'm going to use the let keyword in JavaScript. And I'm going to say we got a start index, and that's going to be at the start of the array, which is indexed at 0. And then we're going to have an end index, and that's going to be at the end of the array, which would be heights length -1. That's how you get to the access the end of an array. And then I know I need to have like my max area. So like, let's say this is the max, what do they call it? Water area, max water area. Or you can call it max area. I'm just gonna call it max water area. And let's start it at 0 since we really don't know anything now. And then the thing I wanna do, a lot of times when you're doing like 2-pointer solutions or things like that, or you're squeezing something together, you really can't just loop through normally. You really do need to, most of the time, use a while loop. Sometimes you can, if your pointers are moving the same direction, you can just loop through with like a for loop. But in this case, I want to use a while loop, and the point at when I want to stop is when start index, while start index is less than the end index. So when those, I'm gonna move the start index forward and move the end index backwards, and when they meet each other, then I'm basically done. And then at the end, actually, I'm just gonna call this like max. I'm not even going. So then at the end, we return max. So I'm gonna go ahead and do that because I don't want to forget to do it later. And so I'm gonna add some little space between here. And so now inside of here, what do we want to do? Like at this point, we need to, if we're at start index and end index, these are our pointers. What we want to start doing, we will be here and here. What we want to do is take these heights, and like I said, the water line. You need to figure out we need to figure out where the water line is. 7, wherever it is, we need to figure out where it is so we can calculate how much water is at this step in our iteration. So like I said earlier, the important thing to keep in mind is that the water line is always at the lowest height between the two, like pylons or whatever you want to call them, 2 container walls or whatever. So like in this case, this one's 8 and this one's 7. The water line, the blue line, is at 7 because it's the lowest one, because water can't go over the side. You know what I'm saying? So basically I need to find, I call this like the water line or something like that. And so what I can do in JavaScript is use math min, and I can say for the heights at index start index, compare it to the height at end index. And this is starting to shoot. what can I do? Zoom in or zoom out? Yeah, I gotta zoom in a little bit. So I hope that's not too small. I might have to zoom in back in. Y'all just have to just bear with me on that. But yeah, so basically the waterline is where basically math min gives me the minimum between two things in this function. So the first thing is I'm going to look at the start index height. I'm going to pull out of my heights array. I'm going to pull the value at the start index, which is, in this case, is 1. And then the value at the end index is 7. And so I'm going to compare 7 and 1 and get the minimum, which would be 1. So waterline is going to be 1 in this case. And then the other thing I want to figure out is the max candidate. And I'm calling it max candidate because like this is a new candidate for or we can just call it like water area. Matter of fact, not max candidate, water area. What's the water area? We got the water line. What's the water area? So the water line is this line number. So in this case it's 7. I need to multiply it times the distance between the two sides of wherever I'm at with the index. And I can easily do that because I already have the index number. So I can basically say waterline times, and I can use math. My bad. That's not that. I need to just subtract the end index value from the start index value. And what that'll do, this will be waterline times the distance between the end and the start index. So like in this case over here, it'd be 7 times 7. It'd be waterline number 7 times end index, which in this case is I think 9. And in this case, this is 0, 1. Oh no, this is 8. Sorry, my bad. This is 8. And then this is 1. So 8 minus 1 is 7. So it'd be 7 times 7, which would give us the 49 that we was looking for in that case. So it's kind of just a way to mentally run through our code as we're doing it to hopefully know that it's doing what it's supposed to do. And then what's the last thing I got to do? Well, I need to see if this new water area that I calculated is the highest one that I've ever seen. So I can do that is use math max, and I can compare the current max that I already have to the water area that I'm looking at right now. And if it is higher than the one I already have, then it'll set a new max. If it's not, then it'll just keep the same max I have. So I'm just going through my process. I'm just keeping track of the highest thing I've ever seen, because all the problem, it doesn't care about where it is. All it cares about is you just getting this maximum value. And so all I'm doing is just always storing the maximum value inside this max variable, and then I'll return it at the end. And so it always starts at 0 because I don't really know what it is to start with. And so then after that, this is the part where after we calculated our current kind of like water level, this is the part where we need to decide which pointer to move to start comparing the next water level, basically. And so what we can do is we can say if let's take the height of the start index. So we need to compare the heights of each side and figure out which one I believe is the lowest. And or if they're both equal, we need to do something too. So I'm going to say at the height start index, if the height start index is less than or equal to the height of the end index. So let's say when we're here with this one and here with this one. Basically, I pretty much know, like, if this one's lower, if this one's higher and my water line's way up here, possibly for this one, and then this one's lower, well, I know this one's higher, so I might as well move this one in because it's lower than this one, and I know that it's better chance that there's something higher in between here than it is of something higher being in between here, since I already know this one is lower than the end one that I'm currently comparing to. And so it's just kind of a way to help it just move along a little bit faster and more optimally. And yeah, that's basically the way that at least I was thinking to do it. So if the first one's lower than and if it's equal to, then I just move either one of them. Like, it doesn't even matter. But you can't move both at the same time, because then you'll miss one. You'll miss a comparison that you really need. So you always need to move one at the same time, so you make sure you're getting in every combination. But by prioritizing moving in the lower one, you're getting to, it just makes more logical sense that you may find a higher one by moving the lower one in. So in this case, I'm going to move start index plus plus if it's lower. Else, if the other one, if the end of it is lower, then I'm going to move the end index backwards and like squeeze it in. So basically, like when I move the first time, I'll compare first one, last one. This one's higher, so I'll move this one in. Then this one's higher, so I'll move this one in. And then now this one's higher, so I'll move this one in. Now they're equal, so I'll move this one in. And then now this one's lower, so it'll move in. And so like so on and so on, so they both squeeze together and get to the same point. And then at that point, I'm done. There's nothing left. There's nothing to calculate when they're both equal to each other, the indexes. So because then you're in the same like pylon or whatever. You're in the same container wall, and that's not a container. So okay. So anyway, yeah, I think this looks good. Like tracing through this, I have a start index. I'm using heights, length minus 1 to get the end index. So start my max at 0. While start index is less than end index, I calculate the water line by finding the minimum heights of the start between the start line and the end line. And then I calculate my water area doing water line times end index, basically the width or the length. So end index minus index. And I could make more variables to hold this stuff, but the reason I'm not going to do that, because that does start to use space, and it starts to use operations, and it does add up. So if I'm coding for a company, of course I want to make it readable, as long as it's not sacrificing too much time complexity or operations or like memory, just holding variables and stuff. But in leak code or like in coding challenges, I kind of prefer only to set up variables when necessary, just because you're going to see in the end when I run it that those variables do matter. Like if you use less variables, then the code runs faster. So especially at scale, once they give you a problem that has like, 100,000 entries in it or something, or 10,000, whatever. So anyway, yeah, I get to here, then I need to recalculate my max, figure out the max between the new water area and the max if it's higher. And then here, if the height of wherever I'm at is lower than or equal to, then I'm going to move it over. Else, if the back is higher, then I'm going to move it back and test the new. Then I want to loop back to the starter here and test the new start and end index. And somebody said, what is my t-shirt? It's like Mercer University. It's my the college I went to. Yeah, anyway. Yes, keep going. So like if you're in an interview, some interviews they'll let you run this they'll let you run the algorithm with some kind of program like HackerRank or some other tool that they have that can run code. Some interviews I've been in, they don't let you run the code. You write the code and then you explain the code and you trace through it to show them that it's working. And so sometimes that's the case. Sometimes you're not going to be able to run the code, and they literally want you to prove to them that it works. And so how we have to do that is, I'm trying to find a way to do this fast without a bunch of let me see. But anyway, I'm trying not to take a lot of time to do this, but I think there's no way around it. I have to just... So how I like to do that is I like to create variables in comments and keep track of all my variables and just trace through the code with the interviewer, and just to make sure that it works. So bear with me. This is going to take a little bit of time. I'm going to use a shorter example So let's say we got heights here. I'm gonna use heights, and then I'm gonna put this. I'm gonna take some of these out so I don't have to do so much work. Yeah, I'm gonna take it out to like that, like that, like there, like that right there. And then let's put output here. That's the output of the program. What are the variables do we have? We have start index. We have end index. We have max, whatever our current max is. And then we have like this too, which is like the height at the current index. It's gonna be a lot of variables here, but it's gonna make sense in a second. And then we have water line and water area. I'm probably not gonna trace through this whole thing because it's gonna take forever, but more than that, I guess when you start doing these medium problems, they got a little bit more stuff to them. It's not like terribly difficult, but it's definitely not as quick to explain as the to trace through as some of the easy problems I've done on here before. But anyway, let's go through it. So literally start on the first line. We're gonna set start index to 0. And the reason an interviewer might make you do this is because they don't care that necessarily you got the right answer at some places. They care more about how you think and how you trace through code and how you debug your code if you find issues. When you do this, if your code is wrong, you may find the issue literally by just tracing through it manually. And so they want to see how you think and how you solve and how you change your code after you find issues and debug and how you talk through things. Like so it seems pointless, but that's why they would ask you to do it. And I just spit all over but that's cool because this is what they make you do when you just into it and you trying to figure it out. Like you just start spitting and stuff, you know. But anyway, so the height's length, the length is 1, 2, 3, 4, 5. So length minus 1. So end index is going to be set to length minus 1, which will be 4. So 0 to 4 is the start and end index. And then now we start going in here. Well, max is actually supposed to be up here. Max is 0. So we got that there. So max got set to 0. Now we start going through our loop while start index is greater or less than end index. So of course it is right now. So we're going to go into this loop. Water line is the minimum of height at start index and heights at end index. So what's start height at start index? Index 0 is 1. We know it's 1 and 7 at this point. It's the start and the end of the array. And so we need to take the minimum to set that to water line. The minimum is 1. So let's set that variable up there to 1. Now we need to calculate water area. It's water line 1 times end index minus start index. End index minus start index is 7 minus 1, which gives you 6. And so, yeah, 7 minus 1. See, I got to do freaking math. The program's supposed to do the math for you. I got to do the math myself. So end index minus start, which is easy, you know, it's 6 or whatever, but still, I'm like, in front of all y'all, I don't want to mess up this freaking multiplication. So this is just 1 times 6. So this will just be 6. 7 minus, yeah. All right. So this is 6. Water area 6. And since max, that's the important thing about making max 0. So you can always set the new max. So which is higher? Math max 0, which is in max, or the water area we just calculated, which is 6. 6 is higher, so now the new max is going to be 6. And that makes sense though, because when you look at it like this, it's like the height is only 1 on this side and on the end it's 7. And so then the water can only go this high, so it's really the length of whatever the distance is between here minus times the height. And I screwed up here. See, that's why you have to trace through this stuff, because what did I do? This I just basically screwed this up. This is supposed to be end index minus start index. I was using these values. Supposed to be using these values. 4 minus 0 is 4, and then that's time 1 is 4. So water area is actually 4. My bad, I screwed up there. And that makes more sense because it's just one height times the distance of this array, which is 4. So it makes sense. See, that's why you trace through this stuff. And then we get to this line, we say is the height, if the height at the start is less than or equal to the height at the end, then just move up the start index. So if it's, my bad, if it's lower than or equal to it, it is lower than because it's 1 and it's 7. So we're going to move up this index to 1. And we're going to start. We're going to skip all this, and we're going to skip the else condition, and we're going to go back to the top. And we're basically going to recalculate our height start index and heights end index, because now start index is 1, so it would be 8 now. And then we'll find a minimum between 8 and 7, which is 7. So our new water line is going to be 7. Let's erase this. My bad, erase that. And then the water area is going to be water line 7 times end index minus start index. So end index minus start index is still going to be 3. And so, yeah, so that would give us 3 times, shoot, now I forgot what the heck the water line is. Yeah, water line 7. So 3 times 7, 21. So that would give us 21 savage water area for this one. Yeah, and so is that our new max for this line here? Yes, that's bigger than 6. So it's saying compare 6 and compare the new water area. 21 is over 6. It's higher than 6. So now the new max is going to be 21. And we would just keep going through this loop. I can keep going through it. If I was in an interview, I would keep going through it. I don't, shoot, I really don't feel like going through all this. Let me see if I can go through it a little bit faster. So yeah, we get here, new max. I'm going to erase all this stuff out. And then we're going to see which one is smaller. And shoot, I screwed that up. Shouldn't erase that. The smaller one is the end one. So we're actually going to move the end this time back -1 off of that. Going to erase these. And now we're going to reset these to new values 1 and 3. And so the 1 is still 8 and the 3, 0, 1, 2, 3 is going to be 3 height there. And our water line, we really don't have to look at this anymore because we know what these calculations are going to be. So we know our water line is going to be 3, and we know our water areas is going to be 3 minus 1 is 2 times our water line. 2 times 3, which will give you 6. And that's not higher than the max, so we can go ahead and just end on that note. But we need to move. This one's lower, so we need to move our index back. So we're going to move the index back to 2. That's going to change these two variables again to, it's still going to be 8. And then this one's going to be 0, 1, 2. It's going to be 6. And our water line is going to be the lower one, 6. And then our calculation is going to be 2 minus 1, which is 1 times 6, which is going to give us 6. Times 6, which is going to give us 6. And 6 is not higher than 21, so we know that's not going to work. And then the end one is still the lower one, so we're going to move it back to 1. And at that point, once we get to that point, start index equals end index, we've gotten out of our while loop here, and our max is 21. So that is the 21 is the answer for this problem. Once we get down here, we're going to return the max, which is 21, and that should be the solution for this problem. And so what I'm going to do now, I know probably y'all waiting on this, is LeetCode.com. What I'm going to do now is run this on LeetCode. So I'm going to erase all this. I'm going to add a test case. Wait, why can't I open this up? Yeah, I'm going to add a new test case because I had changed my test case to this. And how can I put the answer in here? Oh, I guess it doesn't care. All right, yeah, so this is my new test case. And LeetCode lets you run this here. So sometimes in an interview, you might have to run this. Sometimes you won't run this. But I need to run it, so let me go ahead and run it and see if I got the code right. Yep, so got, for our problem over here, 49 was the output. My algorithm sent out 49 as expected. For this second problem, 1 is the output. I put out 1 as expected. And then this was the test case I just ran manually. The output was supposed to be 21, and I got 21 as expected in my algorithm. And so that's good. Like, my code's working as expected for those 3 test cases. So the next thing an interviewer would ask you to do is big O notation. So big O notation is how we denote the space and time complexity between an algorithm as it relates to the size of the input. So the size of our input here is the heights, the length of the string, how many heights, how many walls in the containers that we have to compare, and how many are we working with. That could be 6, that could be 8, that could be 1,000,000. You know, it just depends on the program and on the data that needs to come through it. And so how does our algorithm perform according to the scale that's put in it? Does it perform worse as the scale goes up? Does it perform linearly as the scale goes up? Or does it always perform the same as the scale goes up? As far as space and time complexity, the time that it takes to run, the operations it has to do, and the space that it has to use to accomplish the processing. So big O notation in this case, what is tied to the length of our heights array? This isn't, because this will always run the same. This is tied to the length, but it's just a number. It's just a constant operation just to get the n index. So it's not really tied. It doesn't run. It still runs this one time because this length is a linear operation to get this out of an array. This just runs once no matter how big the length is. But when we get here, moving these since we're only just adding 1 to these each time, then moving the start and end index here is directly tied to how big this array is because if like the start is 0 but the end is 1,000,000, then we got to keep moving in like, you know, 500,000 times or 1,000,000 times really to get in to the point where we hit this condition. So all this code in here would run 1,000,000 times if the algorithm had 1,000,000 heights in this array. And so that really is everything else in here. I mean, these run 1,000,000 times, but they run one time every iteration. So there's no nested like loops in here. There's nothing in here that's tied to any size of anything as far as how many times it runs. All this stuff inside of here run once, but it's kind of hard to explain. Like this stuff, nothing in here is running like as this runs more like 1,000,000 times. Nothing in here is like running multiple times inside of each iteration of its run, if that makes sense. And so because of that, that makes our big O time complexity, big O of n, what's called linear time. So it's really the algorithm is tied to this, directly tied linearly to the size of our input. If there's 1, then more or less we've reduced to 1 operation. It's not exactly 1, but it had to be at least 2 because that's the constraints. So it'd be like 2 operations here. Or if it's 1,000,000, it'd be 1,000,000 operations reduced. Like this ain't exactly just a simple loop, so it's actually not exactly linear. But big O notation is all about the worst case and all about, or not all about, but it reduces down to one of these, you know, whatever is at scale closest to linear. And this loop is closest as far as how it scales to big O of n or linear complexity. And in time, space complexity, we're not using any, besides for the array that comes in, that doesn't count in the big O notation. It's about what your algorithm is doing. And our algorithm does everything it has is basically just constant variables. There's nothing in here. There's no like extra arrays we're creating or hash maps or stacks or any other data structure that's being added to that is based on the size of our input. It's just simple, constant operations to set values as we're one by one processing each thing. We're not really holding any state. Like we're just going through. I mean, we're not holding any state beyond just where we're at in the current iteration of the loop is what I mean. And the other state that we're holding is just constant. That we're holding the whole time is just these constant values. So I know it's hard to explain. Go look up big O notation, and it maybe help understand kind of like how that works. So yeah. Anyway, that's the space and time complexity. Oh my bad, I didn't even say what the space complexity was. So in that case, if we're not, it'd be big O of 1 or what's called constant space. And so yeah, it's just constant and it's not really directly tied to n, which is the length of our string. So that's great, and that's something the interview would definitely ask you to explain, or at least they usually don't go too much depth in that unless you get it wrong, and then they kind of will probably try to help you or bash you, or whatever the case is, depending on the interviewer. So the last thing I need to do is submit to LeetCode. Will have a bunch of test cases that they'll run, more strenuous test cases, a lot more test cases, and they'll give you kind of like a time score or whatever. And we can see if I'm just wrong, if my algorithm's wrong, as far as it may work for these 3 test cases, but it may not work for all of them. So in this case, it actually did run pretty well. Beat 91%, which that's probably not true. This, you gotta take that with a grain of salt. Weird that it would beat 98%, and then this memory beat 43%. But basically, against all the test cases, I got the right answer. So that's great news. That's usually a pass. Space complexity, time complexity, pretty good. That's one thing I explain. Like if you go beyond big O of n, typically in an interview, you can learn about the different complexities there are. There's like n squared, there's n log n, there's log n. Like there's some that are worse than linear time. And a lot of times if you get a solution that's like n squared, the interviewer may ask you like, how can you do this better? How can you do this in n squared? Some solutions you have to do in n squared, but like it just depends. So it's just important to know that. But anyway, yeah. So you can analyze. LeetCode lets you. Oh shoot, I did too many today, so I can't do it. But I did it earlier, and it was big O of n, so we were good there. And yeah, that's really it. Like I'll go back over here to the problem. That's pretty much it. Like this is the problem. Containers with most water. Hope that makes sense. It's called container with most water. Somebody just asked that. I'll answer a few questions here. Yo KG, love your content. What's your thought on new graduate roles getting posted on GitHub? GitHub.com? GitHub the company? Like they're hiring new graduates? Are you saying like they're getting posted on GitHub like in a repository? Anyway, like any new graduate roles, man, I think that's great. Like that's been a much needed thing in the industry since kind of like midway through the pandemic, or maybe at the end of the pandemic. It seemed like a lot of less companies were hiring new devs out of school. So it seems like that's kind of starting to turn around a little bit, maybe, but I don't know. So anytime I see that, I mean, my opinion is just get more people out here into these roles. Yeah, this is the problem for anybody that didn't see it. You kind of can't see the chart at the same time, but anyway. Yeah, so let's see. They've been getting posted on this repository that came across. Oh, yeah. So they actually put them in a repository. I haven't heard of that, man. Like, maybe DM that to me. I haven't heard of that, but I heard of the repository they have, like, coding without whiteboards, which is kind of counterintuitive to what I'm doing right now. there's this repo that it's called Interviews Without Whiteboards or something like that, where they host a bunch of companies that don't ask leak code questions like this if you just want to completely avoid it, which it is avoidable. Like you can avoid it and just go for companies that don't ask questions like this. But yeah, there's a lot of companies that do that you might want to get into. So yeah, just send it over to me. I mean, that's good. If there's I mean, it's probably a good thing. I haven't seen it, but I can review it. Can I get a job without knowing leak code? Yeah, that's what I just said. Like it's a lot of companies that don't ask leak code. Some don't believe in it. Some ask more practical questions. Like I've had interviews where they asked me to like build React components, like front end interviews, or build a. I had one that told me to build a directory tree, like a file system tree, like into a HTML page with JavaScript. I have interviews where they had me make a Minesweeper game. So like, there's not all of them ask that, so you can avoid it. Ask your interviewer when you interviewing to make sure that if they ask that or not. But I mean, the thing is, certain companies like these FANG companies, the big ones like Amazon, Facebook, or Meta or whatever, Microsoft, Netflix, and what's the other one? Did I say Amazon? Apple. They're going to ask these. So if you want to work for one of the big boys like Airbnb, they ask them. Like a lot of these big tech companies, Uber, I don't know, just name one. Like most of them do. If they don't, it's highly probably highly publicized on the internet that they don't. It was one company, was it Square or Stripe? Either Square or Stripe that didn't ask coding challenges. I can't remember. I don't think it was Square though, or Block or whatever. But it was one of them that was like notable. Let's see. You teach JavaScript. That's what I work in most right now, but I don't teach it. I'm not doing any like mentoring or anything like that. I mean, I teach it to my coworkers if they need some help, or I teach it to myself if I need to level up on something. But I'm not. I mean, I teach it on my channel, sorta, like through my content. So I guess that's true. Are you streaming this on Twitch or just Insta? Yes, it's on Twitch, YouTube, everywhere. Facebook, Instagram, X, all that stuff. Let me see if I got any more questions or comments. KG.codes became the #1 member on the team. What does that mean? I don't even know what that means. I probably don't understand TikTok. What problem is this? This is called container with most water. Basically trying to find the combination of size that will give you the most water coverage or area. Great. Joshua said, great content. Keep up the great work. I appreciate that, man. Love to see this, King. Hey, I appreciate that. Tyler, appreciate that, dude. Just look at the solution, bro. Like, I don't know if you're talking to me or talking to somebody else. Let's see what website it is. This is leetcode.com. LEET code.com. Java, no, I'm using JavaScript. Java is much easier because you don't have to worry about a lot of memory management. You don't have to in like JavaScript's a higher level language too. You don't have to worry about memory management there either. But yeah, Java's that way too. Java's object oriented, a little bit more verbose than JavaScript, but I love it as a language too. I mostly use it for like Java for like back end stuff in the past, building like web APIs and services and stuff. I'm barely learning C++. BK said, I'm barely learning C++, and my roommate was doing some Java homework and it seemed confusing. Yeah, man. Java's probably confusing, not even just the language, but because it's like object oriented, then you start getting introduced to interfaces and classes and inheritance and like polymorphism, and you start getting introduced to all these concepts, like, yeah, encapsulation, like private and public variables, and it starts to get a little bit more complicated when you start learning all that stuff. JavaScript has it too. I think since JavaScript is more like a scripting language historically, like it doesn't pop out as much unless you're doing like, let's start building with frameworks, or you start doing some really more complicated JavaScript stuff. But yeah, Java, it's like right front and center. Java and C#. back-end language, mostly back-end languages. Yeah. How much harder is Java compared to C++? I would say Java's easier than C++. So there's like lower level languages. There's like low level languages, and then there's like higher level languages. And Java will be considered a higher level. And I don't mean higher level as in it's like better or it's harder. Higher level as it's like farther away from the machine code. So C++, you have to, it's closer to like assembly, like machine code language, like closer to that. It's closer than Java is. And so like it hasn't not as nice syntax as Java as far as like in things done for you abstracted away that you don't have to worry about. Like in C++, you have to worry about a lot of stuff that you don't have to worry about in Java is what I'm saying. In JavaScript and C Sharp, like in Python and other languages like that, which do a lot of stuff for you, just let you just worry about just coding whatever you're trying to code. In college, I learned assembly, and that literally like you don't even have for loops. You literally got to use like go to statements to like if you're doing something, you got to like jump back up and like that was like real close to the machine language. What's your t-shirt? I think I answered that already. I got an internship going into my sophomore year. I brag too. That's dope, man. Getting an internship that early, that's pretty good. I got an internship at Johnson & Johnson going into my... Are y'all just trolling that? Like, everybody got something going on in their sophomore year? Like, that's crazy. Oh, okay. I see. My bad. I don't even understand TikTok. Somebody, okay, Vans, appreciate that. Oh yeah, I haven't seen the repository yet. I'm on my TikTok on my phone now, so I have to do it after I get off this live. But appreciate you sending me that, man. I'll DM you back. Let's see. Yeah, I think that's pretty much it, man. I think should we focus on time? Should we focus on time complexity for interview? Yes. That's the one place you should focus on it. I mean, it comes up in regular in day jobs sometimes. I wouldn't say big O comes up, but bad algorithms come up. And so like knowing how to optimize algorithms, even if you don't know the big O complexity, how to describe that is bad, knowing that is bad is important. But in the interview, big O is a language to be able to discuss the complexity of an algorithm. So you do need to know it in the interview. If they asking you a coding challenge in the interview, they will ask you the time and space complexity after you get done, if you get done. So definitely study that for interviews if you're doing interviews like this. I think I might have tapped out of the question. So yeah, John. Yeah, I think I read all these. Somebody said the problem's easy. I mean, all the problems are easy when you know how to do it, when you learn how to do them. But it takes time to get there. Oh, somebody asked David. He probably not even on here no more. But he asked, "Is this like the trapping rainwater problem?" This, honestly, man, I thought this was the same problem when I was first started doing it, but it's a little bit different. And trapping rainwater, I think, is a hard problem, and this one's a medium. But it almost is like the exact same problem, the trapping rainwater problem. I'm trying to figure out what's different about the trapping rainwater. Trapping rainwater is kind of like, trapping rainwater has, I don't know, man. It is like the same. It seemed like almost the same. But it's a little bit different. But yeah, it's pretty close. Yeah, can you put the example at the top? I think I'm probably going back too far now. I don't know if these people are still on here, but let's see. Yeah, I think that's pretty much it. I appreciate y'all joining. I think I'm gonna hop off of here. Appreciate you joining across all the channels. Follow me. I'm gonna try to do these every Friday. I've been doing good so far. I'm getting better at doing these. I'm probably start trying to move a little bit faster. I try to over explain everything to try to teach people, but I may just try to go through them a little bit faster and then do like Q&As after. But we'll see how that goes. I appreciate y'all joining though. Follow me on any channel, Facebook, Instagram, TikTok, Twitch, YouTube, all of them, X, all that stuff. So, follow each other, like communicate with each other. Like, it's a community on here. A lot of us don't know about each other. I didn't know about it on these different platforms, how many coders and tech people are on here. So connect with each other as well. And DM me if you got any questions about anything, like tech wise, career wise, coding wise, or whatever. Like, just hit me up in the DMs. And yeah, let's talk about it. I appreciate y'all jumping on. I'll see y'all probably next week if I don't see you before then. So I appreciate it.